In this section, we're going to talk about how to get input from the keyboard along with basic mathematical operations like addition and subtraction, multiplication, and division. Here at the top, I have this commented out, but you remember from the previous video where we introduced integers and floating point numbers, or fractional value numbers, and Boolean values, which are either true or false, and strings, which can be just anything that can be typed in, any data really. Now here, what if we want to get input from the keyboard? What if we want to ask the user their favorite color? We might decide we would store that in a variable called color, right? And if we type input, this is a Python command called input that gets information from the user. And what we type next is entirely up to us. Python doesn't really care. This is where you prompt the user. Now, it should make sense to the user, but again, Python doesn't care. It doesn't know what you're really saying to the user. Python doesn't understand English syntax. But here we would say something like, enter your favorite color. And then maybe we'll just print it to the screen, which we talked about last video. So here, whatever the user types in when Python prompts them, that's going to be stored in color, which is a variable, a location in memory that holds information. And then when we print it to the screen, it'll be whatever the user typed in. So if we right click on this and choose run, we'll see the color is blue. And you can kind of see how this is all run together. It's not very pleasing to the eye. We can put a colon up here and a space. It won't change it right now. We'll have to rerun it, but let's go ahead and see what it does. And you can see it just repeats whatever we type in. If we run it again, and let's just say we don't enter a color, we just enter whatever we want, the make of a vehicle, for example. It prints that. Python has no idea what we're asking for. It has no idea what's really being entered. It just prints whatever was entered. That's what this code does. Whatever's entered is being stored at a memory location called color, and then we're printing that variable or memory location to the screen. Now, what if we do something a little different? What if we say, rather than color, what if we say number? And let's say enter a number. We can copy and paste this. And we might say another number for lack of originality. And we'll say enter another number. Now in Python, we can multiply and divide. We can add and subtract. And you guys are familiar with this, but let's say we want to multiply the first number times the second number. Like this. Now if we run this, see that red underline a moment ago, it's because I'd misspelled this. If you see this pop up in your code, you know that you have a syntax error. This is an indication of a syntax error, an error that is caused by mistyping something. Now if we run this, say 3 times 5 should be 15, but instead we see an error. Now this is related to a data type issue. And we learned about data types previously. We learned about what a string is, and we learned about what an integer is. Now, interestingly, whenever we get data from the keyboard is inputted as a string. And Python can't multiply strings. It doesn't make sense. How would you multiply random characters from the keyboard? If they're numbers, if we can guarantee to Python that these are numbers, then Python would be able to multiply them for us. But on the back end inside Python, Python considers these, whatever's entered from the keyboard, it decides that is a string. That's one of the rules of Python, that we assume whatever we get from the keyboard is not an integer, it's not a float, it's not a Boolean value, it is a string. And remember, strings don't have necessarily to hold data that looks like this. It could hold data that looks like this or this. This is this is a string. Oh, sorry, that is a float. This is a string. Even though it looks like a float here, Python considers this a string. Even though this looks like an integer here, to you and I, Python says, no, this is a string. It's a string because you have it enclosed in quotation marks right there and right there. To make it an actual variable, an actual integer, you would need to take off or remove the quotation marks. So similarly, even though we entered a 3 and a 5 from the keyboard, and it looks like an integer to us, Python classified it on the back end. It classified it as a string. So what do we do? Well, now that we understand the different types of data, or the data types, we can handle this in several different ways. One way may be to say something like this. We can say to Python, we can say number equals and let's do the same thing with the other one, with another number. Let's come down here. Let's put some vertical space. This is a little easier to read. Let's paste this in here. And let's change that. So we're saying number is equal to number, which really doesn't make a lot of sense. But look at this integer. What we're really telling Python now is, hey, I'm guaranteeing you, I promise you, that number is an actual integer. It's not a string. It's not a float. It's not a Boolean value. It really is an integer. I promise you that. And we're saying the same thing down here. Another number is equal to itself, but with this integer modifier. We're modifying this number or this string, what Python believes is a string, and we're guaranteeing it. We're guaranteeing this is now an integer. So now when we run this, we should see something that is different. We say 3 and 5, we see 15. Because we guaranteed to Python that this is an integer. Now, this isn't the only way to do it. This is sort of a long method of doing it, but let me show you here. We could do the same thing down here. We can say int and surround number with parentheses. And over here, we could say int and surround the variable name, called another number with the parentheses. And it's doing the exact same thing as it was doing up here, or at least in terms of what we can see in this particular situation. It really is the exact same thing. 3 and 5 is 15. If you're interested, you could also type in double here. I'm sorry, float. And float. And if we run this, then even though we typed in what looks like an integer to us, Python says, okay, I believe you. You say it's a float, and that's why it's putting the decimal. Even though the decimal component is 0, it's still a whole number technically. It looks like to us, Python is treating this as a float. Now you might think, okay, well, what happens if I lie to Python? What if I say, okay, I'm giving you an integer, I promise, but I really don't? What if I have something like this? Ford and Honda. Then it says, hey, you lied to me. You told me that you were looking for an integer. That's what I was supposed to get, and it didn't happen. And the program crashes. Appropriately enough, called a value error. You don't have to understand all the errors, but when you see this, after a while, these errors at first may look like a little cryptic, but after a while, you'll see that it kind of makes sense once you understand data types and really get familiar with them. Now, interestingly, let's see, there are some other mathematical operations we can do here while we're here. What if we subtract these two numbers with the minus sign? Remember, multiplication was the asterisk. A lot of people want to type in an X. No language uses that. It's all going to be, usually it's going to be the asterisk sign for multiplication. What about subtraction? What do you think is going to happen here? Is there anything unusual? No, that's just exactly what it looks like. What about plus? We can do plus, and we can run this. 5 plus 5 is 10. nothing surprising about that. Division is also similar here. We can, let's just run, and we divide 10 by 5. We can see that 5 goes into 10 twice. In Python, unlike a lot of other languages, when you divide two integers, Python, if you use the standard division sign, which is this sign right here, and this is used in a lot of languages, Python automatically says, yeah, you probably want a decimal number if appropriate. Python doesn't really know when is appropriate, but let me show you when it's appropriate. When you really want a decimal number is when you're dividing by, let's say, something that's not going to divide evenly. 4 does not divide evenly into 9, and we get this decimal number. And that's very convenient because another mathematical operation is called integer division. It's where we're telling Python, yeah, I just want to use whatever the data type actually is. If I feed you two integers, like I'm telling you this is an integer and this is an integer, if I tell you these are two whole numbers, then all I want to see is a whole number, which can be confusing because it makes sense if we're dividing, 10, whoops. It makes perfect sense if we're doing 10 divided by 5, but it doesn't make a lot of sense for us when we do 9 divided by 4. Those don't divide evenly, but Python is almost acting like it does. This is called integer division. When we feed two integers in, we divide one by the other, and the result, the fractional result of that, remember the fractional component was 0.25 a moment ago, like here. With integer division, that's simply chopped off. This is called, it's truncated. It's truncated, it's removed, it's sliced like a knife coming down and slicing it off. In other languages, this usually happens just with the division sign. But with Python, Python is smart enough to say, hey, I know that when you give me two integers, you probably want the decimal. But that's the difference between division and integer division. You can experiment with this on your own. There is also another mathematical operation you should be aware of. The asterisk. It's not double multiplication, although it kind of is in a roundabout way, but not really. When we take in, let's say, 3, and the other number is going to be, this is called a power of. So you remember powers is a number multiplied potentially times itself that number of times. So let's say 3 times. So we're taking in the number 3, and in math you might write this as an exponent of 3. So 3 to the exponent of 3, or 3 to the power of 3 is 27, because 3 times 3 is 9, and then 9 times 3 is 27. You probably won't need to use this very much in this class, but the book goes over it, and it is right. It is a valid mathematical operation. Now, there is one other thing that you should be aware of in Python, in fact, every language. When we come over here, and we can control, in Python, the order of operations with parentheses. And we're not going to get too deep into math, don't worry. This is pretty much all the math we're going to talk about all semester. But order of operations does impact sometimes other things as well. Normally, in math, if we say 5 times 2, whoops, let me type this right here, plus 8. The order of operations in math indicates that multiplication occurs before addition. And if you don't remember this, you can go Google it. You won't need it for this class, but you could go Google that and relearn that sort of elementary math that the order of operations, multiplication is a higher order than addition. So if we run this, this should show 18, because 5 times 2 is 10. This happens first, then plus 8. Oh, we're still getting this above. Let me get rid of all this so it's not impacting what we're doing here, because we're done with that. Let's run this again, and it's 18. What if we do this, though? What if we say plus, and then the times over here? What do you think it's going to say now? Well, the order of operations says multiplication happens first. 8 times 2 is 16. Then 16 plus 5 is 21. That should be our answer, and it is. But we can impact the order of operations in Python and any other language that I'm familiar with by putting in parentheses. And so now the answer is going to be 5 plus 2 is 7, and 7 times 8 is 56. So we can get different answers, just like in math class back in elementary school, by using the order of operations